Okay, we are on section 2.1, which is modeling with expressions. I think you guys will find this section a lot easier than the last one. So the first thing that we are going to be doing is interpreting expressions. So we're going to be looking at something called a numerical expression. So a numerical expression, and first of all, actually, before I even get into that, we're looking at expressions, which is different from an equation. So an equation has an equal sign, an expression does not. So that's the major difference. So a numerical expression is an expression that contains only numbers. So an example of a numerical expression could be something like 2 plus 3, or like 5 minus 7 plus 6. So you'll notice it's numbers that are broken up by plus or minus signs, and there's no equal sign. The next one is an algebraic expression. So an algebraic expression is an expression that contains at least one variable. So just so you remember, a variable is a letter. So we typically have variables to represent something that we do not know. So an algebraic expression could be something like x plus 5. So it has at least one variable. I'll do a couple more examples. 6x plus 12. Okay. We could also have something like y, right? It has at least one variable, so that would be an algebraic expression. Okay, so this next part, it might be helpful if you have some colored pens to use, because I'm going to be color coding this. So here we have an expression, okay? So we have, we would just call this, it's an algebraic expression because it has at least one variable. So we're going to look at some vocabulary words. So the first word we're going to look at is terms. So again, it would be helpful to have colors. So I'm trying to put this in simple terms. So it's just parts being added or subtracted. Okay, so terms are just parts being added or subtracted. So I'm going to underline the terms. They're 2x, negative 3y, and 4. Okay, so in this case, there are 3 terms. So I'll list them out here. 2x, negative 3y, and 4. So those are the terms. Okay. The other word the other vocab word that we are going to look at is coefficient. So coefficient. Some of you might have heard this word before. So a coefficient is the number in front of the variable. So number in front of the variable. Okay, so remember, variable is just a letter. So coefficients are numbers in front of variables. So I see that there is a 2 in front of the variable and then a negative 3. Notice I keep that sign. The 4 is not a coefficient because it does not have a variable. So if I were to ask you to list the coefficients, it would be 2 and negative 3. All right. The last word we are going to look at is constant. So constant is a number without a variable. So remember, constant means it's not changing, and variables vary, they change. So a constant is a number without a variable. So in this case, the constant is 4. Okay, so it's just a number without a variable. All right, so we're going to go ahead and continue. So this top portion was really just vocabulary. Now we're going to get into some problems. Now this problem looks super overwhelming because it's a word problem, and I know we all don't love them, but we're going to kind of, it actually is way easier than it looks. Okay, so we have George, and he is buying watermelons and pineapples to make a fruit salad. He buys W watermelons. Okay, so they're using W to represent watermelons at $4.49 each, and then P pineapples. So they're using P for pineapples, and those are $5 each. So we want to write an expression to represent the total cost of pineapples and watermelon. All right, so we know that it is $4.49 per watermelon, and W is represented by watermelons. So we could say $4.49 per watermelon. So that means if I wanted to know how much it costs to buy 5 watermelons, I would plug in 5 for W. All right, but we want to know the total cost of pineapples and watermelons. So I'm going to add now watermelons or pineapples are $5 each. So it's $5 per pineapple. Okay, and that's it. That is the expression to represent the total cost of watermelons and pineapples. So it's $4.49 per watermelon plus $5 per pineapple. All right, this is a different type. It's kind of weird, so you just have to get used to the process of it. So we have the price of an item plus 15% sales tax. So first of all, we don't know what the price of an item is, so we're going to use a variable. So I'm going to say X is equal to the price of the item. And I bet after I do this one, you should be able to do the next one on your own. Okay. So X equals the price of the item. So we have the price of the item plus 15% sales tax. So that means the price of the item, which is X, plus, so I can't just say 15%. I can't put that in my calculator. So what you have to do is change it to a decimal. So you move the decimal places 2 places to the left. So this would be plus 0.15%. But then you have to ask yourself, 15% of what? So if I'm doing sales tax, I take 15% of the price of the item. So it should look something like that. So we have the price of the item plus 15% sales tax on that item. But looking at this, we could actually combine this even more. So if you notice, they both have X's. So we can combine like terms. And remember, if there's not a coefficient in front of the variable, it's 1, that imaginary 1. So 1 plus 0.15 is equal to 1.15x. So this expression represents that statement. Okay, let's go ahead and try another. The price of a car plus 6.5% sales tax. So again, we don't know the price of the car, so I'm going to say X equals the price of the car. All right, and then plus 6.5% sales tax. Okay, so we have the price of the car, which is X, plus 6.5%. So again, we want to move the decimal point 2 places to the left. So that would be 0.065. And remember, sales tax comes from the item. So it's 6.5% sales tax of the item. Once again, we have the same variable, so we can combine like terms. There's that imaginary 1 in front of that X. So 1x plus that would be 1.065x. And that would give us the expression. All right, last one. The original price P of an item less a discount of 15%. I know we don't normally say things like that, but just getting you prepared for what you're going to see on your homework. Okay, so P is going to be the price of the item, which we obviously don't know. All right, so we have the price of the item. Now, instead of saying plus, it says less. So typically when we hear the word less, that's associated with subtraction. It doesn't make sense to add it. So less a discount of 15%. And that makes sense because we would, obviously subtract what we are taking off the discount. So 15% turning it into a decimal would be 0.15. And remember, it's of that item. So 15% of that item. So this is an invisible one. We can combine like terms. So this would be 0.85p. And that totally makes sense because that means you're really going to just pay 85% of the price of the item. All right, that is it.